when there is no need of having the information of this event of IO to other process that leads to an unwanted information. Suppose if it is executed based on priority, then it is called as a preemptive. If it is not, then it is called as a non-preemptive. The throughput indicates the total number of processes required to be executed in 1 unit time is called as throughput. Hello and warm welcome to one and all. It is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's session, you will learn about the threading issues. In the previous class, you have learnt about the threading models. In today's class, you will learn about the issues of those threading models. That means thread cancellation. What is the meaning of thread cancellation? During the execution of a process, when one of the thread is to be cancelled, that is also possible. That is called as this. In this case, thread cancellation means terminating a thread before it has finished work. That is called as an abnormal termination. There are two approaches for this. One is asynchronous cancellation, which terminates the target thread immediately. In case of asynchronous thread cancellation, what about the synchronous cancellation? It defers the cancellation process and allows the target thread to be periodically checked if it should be cancelled. What is the difference between this? When you have an asynchronous thread cancellation, when you have an asynchronous thread cancellation, if you, in the user space, if any request is sent to delete or cancel the execution of a process, that terminates the entire execution process immediately. That is called as asynchronous thread cancellation. What is the meaning of synchronous cancellation or deferred cancellation? It periodically checks for every 2-3 seconds whether the thread is to be cancelled or not. If it is not yet terminated, let me check once again. So on, this process is continued. This is called as deferred cancellation, also called as synchronous cancellation, also called as normal termination. Which is the next type of the threading issues? Signal handling. Signals are used in Unix systems to notify a process that a particular event has occurred. That means whenever an init is used, the process is created. In Unix operating system. So whenever an event occurs, the process is notified. The process is notified about the type of event occurred. In the form of a signal. If that is the case, now when a multi-threaded process receives a signal to which the thread it must be delivered, it can be delivered to all or a single thread. That means whenever an event occurs, which is that event? IO event. Let me call this as IO event. This must be notified to one single process or to all of the processes which are running in the system. That is possible. When there is no need of having the information of this event of IO to other process that leads to an unwanted information. That is the thing you need to understand here. The third is security issues. Because of the extensive sharing of resources between multiple threads, there are many other issues that you might face in multi-threaded process. The same thing I discussed here. Whenever an event occurs, this process does not require any of this information. Only this one thread is required with this information. So if I deliver more information to it, what is the use of it? That is, the information of this event is given to the other processes. That is the thing. Pointing out some issues here is just to study both sides of the same coin. CPU scheduling. What is the meaning of CPU scheduling? It is a timetable. When the CPU needs to execute this process, when the CPU needs to execute the other process, and when the CPU needs to execute one more process, so on and so forth. This is scheduled. This is timetable is given by the operating system. That is called as CPU scheduling algorithms. We have different types of algorithms there. Let me take you into the details of it in the next session. But let me here explain about the CPU scheduling algorithms. It is a process which allows one process to use the CPU while the execution of other process is on hold. That means when process P1 is held by the resource, held by the system, and in the meantime P2 wants to use the resources of this P1, that is called as the CPU scheduling algorithm. That means the CPU scheduling comes into picture when we have the process P1 which is on hold and P2 wants to make use of the resources of P1 so that the completion of execution is done with P2. That is called as this. Suppose due to the unavailability of any resource like IO, thereby making full use of CPU. The same thing. When it is on hold, the resources utilized by this process P1 may be granted to process P2 so that P2 can complete the execution of the system. That is the thing. The aim of CPU scheduling is to make the system efficient, fast and fair. That is to increase the performance of a system, we use the CPU scheduling algorithms. If that is the case, we have preemptive and non-preemptive scheduling algorithms in case of this. What is the meaning of preemptive scheduling algorithm? What is the meaning of non-preemptive scheduling algorithm? Let me clarify you this. Tasks are usually assigned with priorities. That is, priority 1 is assigned to process, priority 2, that is the next immediately after this process P1, execute process P2 with this priority. So that is what the priorities we will mention. So similarly, the operating system maintains the priorities among different processes running in the system. So if that is the case, at times it is necessary to run a certain task that has a higher priority before another tasks, although it is running. Therefore, the running task is interrupted for some time and resumed later when the priority task has finished its execution. That means P1 is being executed. When P1 is being executed, suppose if P3 comes into the picture with higher priority, then it stops executing this process P1 and allows P3 to complete its execution, and later it resumes the execution of process P1. That is called as a priority scheduling. So if that is the case, we have two different types of priority scheduling, that is preemptive and non-preemptive. This is called as preemptive scheduling. Suppose if it is executed based on priority, then it is called as a preemptive. If it is not, then it is called as a non-preemptive. The preemptive scheduling is prioritized. The same thing. The highest priority process should always be the process that is currently utilized. Example, round-robin CPU scheduling algorithm. If that is the case, we have non-preemptive as well. What does this mean of non-preemptive? Let me take you into the details of it. A running task is executed till completion. It cannot be interrupted when a process enters into the state of running. The state of that process is not deleted from the scheduler until it finishes the service time. That means process P1 is being executed. When process P1 is being executed, suppose if any other process like P3 enters into the system with highest priority, if the operating system adopts this non-preemptive CPU scheduling, then it won't kept this on hold. It will not keep this on hold. It will continue the execution of process P1 once when it enters the running state, and as soon as it is completed, it gives priority to the next process which is under requirement. That means the process which needs to be executed under priority is continued with resources allocation only once when the P1 is completely executed. That is called as non-priority, non-preemptive CPU scheduling. These both, preemptive and non-preemptive, are the different types of shortest job first scheduling algorithm. Please make a note of it. We have an SJF, that is shortest job first scheduling algorithm. We have two different types. One is preemptive and the other one is non-preemptive. These are the two different types of this. Then what is the criteria it considers for performing the scheduling algorithms? The first one is CPU utilization. What is the purpose of using the utilization of CPU? System must be efficient, fast, and the performance must be good enough. In order to do that, to make out the best use of the CPU and not to waste any of the CPU cycles, that is in terms of time and frequency, CPU would be working most of the time, that is ideally 100% of the time, but it is not possible because few of the resources like IO operations and everything must be carried out. So considering only a real system, CPU usage should range from 40% to 90%, that is from lightly loaded system to heavily loaded systems. That means it can utilize up to 90% of the resources for the execution of these processes. Throughput is the next criteria. Please make a note of it. My dear students, the first one, scheduling criteria, that is CPU utilization, very, very important from the examination point of view. You will get it for 8 marks. Definitely, if you look at the previous year question papers, many a time these questions have been asked. So please carefully listen to it. We have a throughput. Throughput indicates the total number of processes completed per unit time, or rather say total amount of work done in a unit time is called as a throughput. That means the total number of processes executed by an operating system in a unit time is called as a throughput. Throughput can also be defined as the total number of resources required, and the total number of processes executed by the CPU is called as a throughput. Please don't forget to mention the unit time here. This may range from 10 seconds to 1 hour depending on the specific processes. Whether it is a long-term process or a short-term process, it does not matter. But the only thing is, the throughput indicates the total number of processes required to be executed in 1 unit time is called as throughput. First scheduling criteria is CPU utilization, that is to maximize the utilization of CPU varying from 40% for lightly loaded systems to heavily loaded systems of 90%. So that the CPU will not be kept idle at all times. That is called as a CPU utilization, which is one of the criteria. The second criteria is throughput. The third criteria is turnaround time. What is the meaning of turnaround time? Let me clarify you this. It is the amount of time taken to execute a particular process. That is, please understand it carefully here, from here. The interval from time of submission of the process to the time of completion of the process, that is the wall clock time. That means process P1 starts its execution at 5th second and completes its execution at 10th second. Then what is the time taken to complete the process, the task T1? 5 seconds. 5, 6, 7, 8, 9, 10. Includes 10th second. So it becomes 6 seconds to complete the execution of task T1. What is the meaning of waiting time then? The sum of the periods spent in the waiting queue, waiting in the ready queue, amount of time that the process has been waiting in the ready queue to acquire, get control on the CPU. That is called as a waiting time. That means we have different types of queues like IO queue or device queue, ready queue, then job queue. Among all these things, ready queue, the number of time spent in waiting in the ready queue is called as waiting time. Suppose from P1 is the process that is executed from 5th second to 10th second. During this time, if process P2 waits in this ready queue, then what is the waiting time? 6 seconds of waiting time is consumed by the process P2 waiting in the ready queue. That is called as the waiting time. So these are the 4 different types of scheduling criteria that are very, very important. Please make a note of it and explain very clearly and give an example for each of this so that the complete marks can be fetched out of it. Yes, there is one more. Load average and response time. Load average. It is the average number of processes residing in the ready queue waiting for their turn to get into the CPU. That is, as I told you, that the ready queue is the one which is kept in it only when it is ready for execution. Immediately after this, it has to be given to the CPU for execution. The number of processes waiting in the ready queue is called as the load average. But what is the time spent by each of the process is called as the waiting time. Load average, the total number of processes waiting in the ready queue is called as a load average. If that is the case, what is the meaning of response time? The time from which it receives a request and what is the time taken to respond to the request is called as response time. If that is the case, amount of time it takes when a request was submitted until the first response is produced, this is called as a response time. Remember, it is the time till the first response and not the completion of the process execution that is the final response. Suppose if there are multiple requests, 4 requests are there, R1, R2, R3, R4. What is the time taken to produce a response? Maybe this is the 5th second, 6th, 7th second. So these are the seconds in which the requests were given to the CPU. But what is the time taken to produce the first response? That is maybe 8th second. So second response, 9th, 10th. So what is the response time taken here? The first response produced at 8th second. So from 5 to 8, that means 8 minus 5, what is the response time? 3 seconds is the response time. This is how we are going to calculate the time required or the time taken to produce a response. First response to the request of users is called as a response time. So these are called as a scheduling criteria. Very, very important from the point of examination. If you look at the previous year question papers, these questions have been asked repeatedly. So please make a note of it and continue reading these very well. Thank you very much. Thank you one and all. If you have any questions, come back to me. I'll help you out. Thank you.